predictive energy optimization, or PEO, from Building IQ is inherently different than what the BMS providers and the legacy players do. We are able to model the thermal behavior of a building using modeling techniques and the computational intensity up in the cloud. We are able to develop a thermal plan, an operational plan for the building, and we're able to deliver that and control set points either at the air handling unit level or at the zone level, and thereby we are able to drive savings throughout the day.
I'm Jen Jackson. I'm a Director of Product Management here at Building IQ. I've been in the energy space since about 2007. I left the software development world to try and make a difference. I want to show you a week in the life of a building that's running predictive energy optimization. Now, I picked this week because of this very unusual warm day in the middle of the week in an otherwise pretty cool set of days here. So this building goes from about the mid-60s or so on Monday, Tuesday, Thursday, Friday, and on Wednesday all of a sudden pops up to over 75. Some other information that we're looking at on the graph is these two solid lines are the temperature requirements of this particular space in this building. So roughly between 72 and about 74 degrees. That's the temperature bound that the optimizer is going to stay within during normal business hours, represented by the solid green line here. So this is a typical office building. So it's got an early morning plant start followed by occupied hours of 8 to 6 or 9 to 5, something like that. So what we are looking at is a gentle change of set points throughout the day on these first few days of the week, which are quite normal. But what I really want to show you is how the optimizer handles this unusually warm day. And to show you that, I want to zoom into this part of the graph. So what we see here is right around 9:30 or so, the building becomes occupied. And remember, Optimizer has already pulled in the forecast weather information, so it knows it's going to be a pretty hot day. And then throughout the day, it's also pulling the actual weather. So as that information comes in, it knows that it's actually getting quite a bit warmer than the forecast.
And then after that, we are constantly updating the model. So every day, and this is where the day-to-day machine learning aspect comes in. Every day, the model gets updated at the end of the day based on the behavior of the building on that particular day. And you're able to go ahead and use this latest model to predict what's going to happen next day.
So what happens here is it keeps the space at its minimum temperature for quite some time, and then it allows the space to drift up. Now, you can barely see these little blips here where the optimizer is making slight corrections because it is monitoring how warm the space is going to get. So here again, you can see another tiny little dip because it wants to keep the temperature under the maximum requirement until the end of the day. Now, this light blue curve represents the electricity cost throughout the day. So more than anything else, it's going to use HVAC energy when the price of energy was as cheap as possible, and then allow this drift to happen when it's more expensive.
Once you have all this data in the cloud, in our portal, you can find out what's going on. You can find out the challenges that you face to delivering the savings, and you can go back and make adjustments. With standard BMS optimization programs, it's much more difficult to get the data and go back and constantly tune your control strategies.
If we take a look at the savings profile for that building for that same week of time, we'll see pretty consistent savings on the Monday, Tuesday, and Thursday, Friday. But we see energy overages on that super warm day in the middle of the week. That is okay. So the optimizer was doing that to maintain occupant comfort because that's its chief concern. But we still were able to see energy savings on that day. So if you look at it on the whole for this week, we had a net savings of energy. And of course, when you add in week over week, you can see some pretty significant savings start to add up.